Hey everybody, John Grimsmo here and Skye. We're going to talk about heat treat and specifically some of the process improvements that we want to make over the next week.
Considerable amount.
Considerable amount. So we're going to show you guys portions of the process that we do right now, not kind of the whole how-to video, but we're going to show you how we do certain things and some of the improvements that we're going to be making. And then next week, we're going to have another video with all of the improvements being put into action and hopefully see good results from that.
Sounds good.
A recurring theme that will be coming up again and again and again and again and again is flatness.
And parallelism.
And parallel. Yeah, that too. I'm more concerned with flatness, but also parallelism. I'm become obsessed with flatness in so many different ways, lapping, etc. And my wife teases me for the nerdiness of it. But it's one of those, you know, do you know where your husband is on a Friday night? He is obsessing about flatness. That's what it is.
That's great.
So anyway, we make blades, right? And flatness translates throughout the entire process, from heat treat to lapping to surface grinding to machining to assembly to blade centering.
Everything.
It's the core of everything. So what we're trying to do right now is stop it at one of the first sources of warp, which is heat treat.
Yep.
So let me show you this blade right here. Has not actually been heat treated yet, but it's a good example of bow, and I'll show you guys. So this right here is a light box that we had our local buddy Martin Scott make up for us. Just uses a very flat surface, and it lets us see using the LEDs, either white or orange, depending on dealer's choice. It just lets us see the light gap behind the part. So this is bowed high in the center. If I push on it, the light gap kind of goes away, which tells me the two endpoints are touching and the center is high. If I flip the blade over, it'll be opposite. The center will be low, and if I touch down one side, then the other side raises up, telling us it's bowed in a certain way. The goal is not to measure the actual, total warp in this scenario. It's just a quick and dirty visual, like, yes, it's warped, no, it's not, flat, parallel, whatever.
And see where the warp is.
Because sometimes it's right in the middle, and sometimes it's like off to the side. So this is a quick indicator. We use it for handles, we use it for blades, we use it for a lot of stuff, actually. We have 3 of these units around the shop, and they get used. I like it. All right, let's move to the heat treat zone and see what you got going on.
All right.
All right, Skye, you got some blades in the heat treat?
Yep, they're coming out right now.
See what you got.
Get on that. One is a lot softer than the other just because of age, but you can definitely feel them warm up.
Yeah, they
and
are
get
starting
soft.
to warm up.
The inlet line won't get warm at all.
Yeah.
I actually had to move the thermocouple in the bucket because depending on where it is, like it needs to be near the drain lines or else it won't even read the temperature difference until like an hour later once it's all equalized.
Really?
Yeah. Surprisingly. So it's...
Boy, you feel that.
It's warm. It's not hot.
Yeah, so after they've been in there for a little bit, I can touch it. It's warm, like a warm cookie kind of thing.
Coming down to about room temp.
Yep. So explain to me, what is the goal of the quenching plates?
So the whole thing is to both drop the blade and squeeze the plates together simultaneously so that both sides contact the hot surface at the same time. And hopefully one side doesn't start cooling down faster than the other. And then I'm squeezing them to 1,000 pounds of force to hopefully keep it super straight and cool it down super fast.
Why do you want to cool it down fast?
Well, like this steel's not super picky, so I think the data sheet says like within 2 minutes of reaching room temp, you're fine for hardening. But the cooling down quickly is what keeps the steel nice and hard.
Okay.
And speed is important because you...
the blade cools down real fast.
Oh yeah.
Right? Even just in the air.
Yep.
Yeah, you can see the color change.
Yeah, like within seconds it'll start to dull out.
Yeah.
I think it's like you have like 3 seconds or so to get it cooling down before it starts to cool down on its own. Not that I think it's necessarily detrimental, but we're aiming for consistency here.
Yep.
I've got this little gauge, hydraulic gauge, that tells me how hard I'm pressing on the press.
Yeah, we'll give you guys a close-up of that when he's done here.
Which adds consistency to that part of the process.
Consistency for everything. Dude, I see the whole table moving. I've never noticed that.
It's a lot of force.
Yeah.
Can imagine how difficult it was when we didn't have it clamped down.
Yeah. Yeah, there's a C-clamp on the back now, right?
Yeah. And it's been working fine
Good.
as is.
Good,
It doesn't
good.
need to be any more complicated than that.
So when you let go, I want to see the table come up.
Okay.
A little bit.
Yeah.
Quarter inch.
Rebounds a little bit.
It's like you're standing on the table pretty much.
Yeah.
Speed is your friend. I love it. So the goal of what we're trying to improve here is flatness of everything. And like Skye said, if you took a hot blade out and you put it on this aluminum thing, and then waited for a few seconds while you go over here to grab your other aluminum plate and you put them on top, the bottom plate's already sucking heat out of one side of the blade, which is going to make it curl, to a degree. Who knows how much? I'm sure scientists can do all the math, but I'm more practical results kind of guy. I just want it to be better. So he's trying to squish so that both plates contact at the same time, not just put it on the bottom and then the other comes seconds later.
That's kind of the only human error thing we've still got in the process is closing the plates quick enough and evenly enough.
I know some people have both suggested and even done rotating that whole thing 90 degrees.
Sideways, yeah.
So that your blade comes in like this and then the two plates come sideways.
On like a screw vise, like a woodworking screw vise.
Which
and I've seen quite a few different
idea.
makers who have that kind of setup.
Yeah, I think it's a really cool idea. You could also upgrade this to a hydraulic or pneumatic air cylinder thing, but we always talk about the
safety
danger involved in that. You got foot pedals and switches, and you could squish your fingers.
Fingers
you could in
pretty
here
close.
too, but it's more of a 2-3 hand operation. Because he's got one hand on the pliers, the other on the handle, so he's never going to have his fingers in there. And it's a manual device, not a more automatic device.
Yeah, you'd have to try pretty hard to squish your hand in there.
Yeah, I mean you could,
accident.
but yeah, like with anything.
Yeah.
Excellent. 1, 2, 3, 4. So you do 8 at a time because
I've got one
8
left
fits in the
coming
oven.
out. Yep.
Excellent.
And these blades are engraved with the number 1 to the number 8, and they're always put in the oven in the same order, and they're quenched in the same order, and they stay in the same order throughout the whole process, just so we can track to see if there's any consistencies with like, oh, by the time we get to number 8, the plates have heated up so much that they're still warped, kind of thing. We haven't seen anything like that so far, but it's just nice to have the data. So I'm actually going to leave that one in the press just because it's the last one.
Okay.
And now I'll start cutting these out.
So I just want to feel these hoses. Yeah, they're warm.
Yeah. I mean, it's 78. It went up. The water temp in the bucket reads 4 degrees higher on our little temp gauge on the bottom. It'll keep going up a little bit.
Yeah,
Maybe not.
as the temperature equalizes.
Yeah.
Some days you'll do 16 in a day, right?
Yep. When we've got the parts to run.
So the top plate is actually quite warm.
Quite a bit warmer than the bottom plate.
I can
too.
hold it, but I can't. It's warm. And the bottom plate is colder. You're right.
Yeah.
I mean, heat rises, yes, but we're trying to suck heat evenly.
The laser's right here if you want to zap it.
Let's see. Top plate is measuring 81. It's not much.
It'll probably be like 2-3 degree difference
Bottom
at most.
plate's 80, 78, 80, something like that.
So these are stainless steel bags, and they're pretty sharp after you cut into them after this. So I'm trying to use the scissors to get the blades free instead of my fingers.
Yeah, it's really only a few degrees.
Yeah, even when I measured it the other day, it was 4 at most, which is pretty good.
Like this place measuring 73 outside,
Which is about room temp.
and it's like 78, 80 depending, but still.
Keep in mind that this was just sitting in front of the super hot oven
Yeah.
as I opened and closed it a whole bunch of times.
But like the ground is measuring 70.
Yeah, like the
69.
water bucket was 74 before I started, like 74 ambient.
Yeah, now it's at 80.
And it'll all equalize over time, right?
Right. But what Skye and I have been trying to do the past few weeks is isolate every variable and improve every variable. And the temperature is one thing, the differential top temp to bottom temp is another thing. The
Flatness
coolant-
of the parts going in, flatness of the parts coming out.
Yep. So we've got improvements.
Yep. And maximum safety, as in don't put your hands in the liquid nitrogen.
That's a good tip.
Yep.
So the blades have now cooled down to room temperature.
Yeah, like I can handle them easily.
Yep. And within minutes, you're bringing them down to negative 321 degrees.
Yep. And they shouldn't sit for, I think the arbitrary number that I've seen thrown out a bunch is 15 minutes. But obviously faster is better between your quench and going into liquid nitrogen.
Yep.
You kind of want to keep the cooling curve from your highest temp to your lowest temp as linear, straight line down as possible.
Now, one thing I have been wondering for straightness and flatness, is there a possibility that this is causing some warpage somehow?
Yeah, not out of the question because you're hanging, they're splayed out and
Yeah,
you're
exactly.
adding stresses in cryo, but once they're clamped and tempered, it shouldn't
Okay.
get rid of that.
So it might be still a variable we're not going to touch this time.
Yeah, I don't
we'll just
know
leave
how
it,
we
but-
would deal with that at the moment unless
but-
they were clamped in cryo.
Or
which
some
I've
sort
seen.
of straight across thing so that they're all
Yeah, like a
still
machined
vertical. Yeah, maybe. Okay.
little holder,
Do your thing.
make like a fancy carabiner.
Yeah, exactly.
So this isn't super full, so I don't have to lower them down too slowly.
So those are warm, basically.
And
you're-
it's causing the liquid nitrogen to boil vigorously. If this was a brand new fill, it would be spilling out everywhere, boiling over like crazy.
Whoa. So this is cryo cooling, like cryoing the blades,
Yep.
basically. What does that do to the steel?
There's a bit to get into that there.
The 4-year-old version, please.
When you quench the blades, you're stopping the crystal structure from changing back to what it was at room temp initially. So you're keeping the hard crystal structure, but it's with these fancier, more complex steels, it doesn't always get all the way there. So you have a bit of retained austenite, it's called. And this cryo operation kind of completes the cycle as much as possible and removes that last of that retained austenite.
Nice.
So you get like a point, maybe like a half point to a solid point of hardness just from this step here.
With no downsides and
yeah,
actually improvements.
As long as you do the process correctly, there's no downside.
Yeah.
It's just a finer grain structure. It allows you to dump more of your alloying elements into a solution when you're doing your aciditizing step and then quenching.
Solution meaning melting them together kind of thing?
Yeah, instead of, it just ends up being a better grain structure, better steel, better end result.
Nice.
A lot of fancier, like more complex carbide steels actually require this step. They will not get fully hard without it. So
How long are they in the cryo for?
for this, just an hour.
Okay.
Some people
So we got
will
some
leave
time.
them overnight. Some people will leave them for 4 days.
Yep.
Whatever they think is correct.
Yep.
Realistically, I think the transformation happens within like 15 minutes to finish the retained austenite, and there's different schools of thought of the correct length of time and what is actually happening. It's not entirely scientifically solved yet as far as I'm aware, But this is what we do,
Yep.
and it seems to work. So
Steady process, that's the goal here. And like liquid nitrogen's interesting because it constantly evaporates and constantly boils itself
Yeah.
and creates the smoke. So you can't seal it fully, otherwise it'll explode. So if you left it alone, never touched it, it would evaporate in like weeks.
oh yeah, it'd be gone.
It'd be gone
in a month.
Yep. And using it, and
Even having
know.
like an inch left from the bottom and going away for a long weekend and coming back, it's gone.
gone, yeah. So we refill it every 3 weeks or so.
Yeah, 3.5.
Okay. Wrung together.
They
I
are
see.
rung together.
There you go.
That's hilarious.
Okay, so these are made of an A2 steel. We got them heat treated. I didn't put Skye through the process of heat treating these. He's too busy doing blades.
Oh, he
So-
treated some of the old ones.
The first ones, these
Yeah.
ones actually, the thinner ones.
First couple sets.
But he's too busy doing blades, so we sent these out to get heat treated. Vacuum heat treated. They turn nice little blue color and temper, and then we lapped them silly flat. I don't know if you can see any reflections in that.
Just on the inside, right?
Yep. I think the outside was also lapped originally.
Yeah, originally.
Yeah.
The second set was.
Like I'm sure you can see my fingers reflected in that. It's good. I used the 30 micron actually to lap these.
Oh, wow.
So they're flat to about 1/10,000th of an inch.
Which is...
I didn't have time to like get rid of that last tenth, which is fine, I think. So the goal with these is to have two sets, or like two plates,
Yep.
screw them together. You stack up a stack of 8 blades inside. We 3D printed
These guides are amazing. They're
these
so
guides because
helpful.
then they go all the way in, and it lets us stack up 8 vertically on top of each other, so they're not like, you know,
They're
guesstimating.
perfectly aligned, and theoretically off the surface grinder, they're within our tolerance of parallelism. So between two perfectly parallel surfaces on these plates, everything will be squished nice and flat, and it will hold them in place during temper, which is where the hardness of the blades comes down and it's kind of relieved out of them. They will kind of warp their own way if you just leave them in as is.
Yeah.
But as they're clamped, they will actually hold that flat and straight.
So
position.
basically, you're trying to constrain all 8 blades.
Yep.
You're trying to equalize any warp within them to
Yep.
each other, and then also to the very thick, flat, hardened steel plates. And you're just creating this sandwich that is theoretically perfectly flat.
Yep.
And trying to equalize everything to that. So we originally started using these ones. They're 3/8 inch thick, also heat treated A2, also surface ground flat.
Those were within a tenth as well.
Yeah, we got them silly flat. We didn't lap them, but we got them flat.
They're not
But
flat anymore.
they, because you're screwing down outside, you're pinching on the outside of
Yeah.
the form, and these are kind of thin for what
Kind
we were
of
trying to do.
Wrapping it around the
So
blades.
I can actually see, Ryan, can you get light through there?
Sweet.
So there's definitely a light gap in between. And we can put them on, you know, indicate the flatness and see what it actually is, but that's not necessary.
Visible light gap is too much.
It's too much. And it proved to us that these are too thin.
Yeah.
So months ago, we came up, actually, I think I engraved the date.
You did.
February 2023, because
go.
always date everything that you make, always. Super handy. I didn't date these, I don't remember when I made them. So these are 3/4 of an inch thick,
And yeah.
super flat. They're stronger than the hardware and stronger than the heat required to like deform everything.
Yeah, and these are a high temper of A2, so the temperature that we're putting them back in over and over and over and over is not changing the heat treat on this steel whatsoever.
Got it. And you used these set for several months,
Oh yeah.
and then I just measured flatness on them the other day, and it was like 1/10 and a half.
It's like almost the exact same.
It was wonderful. So I lapped out like a half, a 1/10, and I just didn't have time to get through the rest because there's kind of a lake in the middle. So I'd have to lap out everything around it to bring it down, and maybe one day we will.
Yep.
But yeah, so I like this. We have 2 sets of hardware here. These are nickel, I believe.
They're, as far as I'm aware, they're kind of like Inconel.
I think they're called N286.
They're
what they're
fancy,
called.
like high heat turbine hardware that
Yeah,
was way too expensive and is definitely overkill.
Exactly.
But they're working great, and the whole theory behind that is that regular stainless steel or like mild steel hardware or whatever is going to react to the temperatures in the temper cycle, and the threads will actually stretch over time, and you'll start to get an uneven amount of clamping force off the hardware as you use it over and over and over again. So these ones should theoretically always be the same forever.
Right, but these guys are good up to like 2,000 degrees.
Oh yeah, way overkill.
So then these are 3.0.
Oh no!
Nice. Who stores it like this?
I didn't do it.
Like this, seriously. These are 3.0 what stainless steel? 316.
316.
316. And I looked up the heat, stress, temper cycles and all that, and the 450-ish degrees you guys are doing here is way below the, I think, 900 degree yield problem area of the screws.
Yeah, like we haven't used this set as much, but it's been fine.
So the 316 screws are significantly cheaper.
Oh yeah.
I forget, this is like $80 for the screws and the nuts.
Like 100.
Like 10, yeah, 10 or more cheaper. And so how do you assemble them now? Let's put these away because these are part of the upgrade. We'll talk about those in a minute.
So we try to keep the insides kind of fingerprint free as much as we can. So these will all get a nice clean down after this.
Okay.
Holding just the sides, you kind of float it, and then you grab your spacers, which are clean enough. Index one side, and then it'll hold itself open because of the single side.
And then you have a
You'll
blade.
grab your stack of blades,
like a heat-treated blade,
outside of cryo, after they've been cooled down or warmed up to room temperature and wiped down so that they are perfectly like grit-free. And you'll take the whole stack of 8, numbered 1 to 8 once again, slide it mostly in, and I think I did this backwards. That's okay. So the tip side is on this side. This is the back side of the fixture. You'll line up the stack. It's hard to do with just one blade because it's meant for all 8 at once.
Right.
And then you can just kind of slide them together.
Beauty.
And I use the tips of my fingers to center these in between the non-threaded part of the bolt. So just like a feel check. And then tighten down the center screws, like by finger tight at first, and then we'll do the corners in a star pattern to try and not bind up anything, kind of like the same concept as tightening on a wheel on a car. And then either torque wrench, which I have set to 10 Newton meters right now, or by hand with a wrench and an Allen key and some calipers or a mic to actually check the width.
See if one plate is tilting.
Yeah, see if it's actually bending or wrapping around those blades like we had in the past.
Yeah.
And we'll just kind of...
Because those thin plates would actually
zap them down.
Warp.
I'm not going to tighten them all the way right now.
Yeah, because you're actually on plastic right now. You're not on 8
crush
blades.
it, yeah.
8 blades are thicker than those plastic inserts.
Not by a lot, but
Really?
by enough.
By enough to clear?
Oh, yeah.
These things fall right out?
These are great.
Good.
This was like a huge quality of life upgrade.
Nice. So we got one for Rask, one for Norseman.
And then star pattern, and then this whole unit without the plastic goes in the temper oven for the whole shebang. And then after tempering for 2 hours, these come out and they actually sit in between our quench plates to cool down back to room temp, which takes about half hour to 45 minutes.
Yeah, there's a lot of thermal mass in this whole setup,
considerable
right?
amount of thermal mass. And that's actually something we had to accommodate for in the oven. So we have to have them sitting so that the open ends of the plates are facing the coils in the oven, the elements, so that the heat can actually get right to the blades. Because if you turn it sideways and have
and the heat goes through here?
Yeah, it's a huge heat shield.
Yeah.
So they don't actually get up to the correct temperature, and we were having issues with the blades being too hard.
Interesting. So in digging down the rabbit hole of trying to figure out, what could be improved in this method, we realized it's very easy to torque it in a crookedness way, because you have this skinny stack in the middle of blades that may be kind of warped and blades that might kind of want to, tilt the whole stack or something.
Also not a uniform shape in a uniform rectangle of tightening, so you're going to have spots where it's going to be putting a lot of force and spots where it's going to be putting less force. Mm-hmm. So it's going to want to wrap those kind of less tension spots And that's exactly what happened with these plates. So we're,
Okay, leave one of these tight for a minute,
okay,
because that'll help, I think.
yeah, finger tight should be fine.
So Skye had the idea to use cant twist clamps.
Stole that from Instagram.
As a completely self-taught machinist, I never kind of bought these ever, but the guys in the shop, in the machine shop, have been using them, and Skye's been asking for this. So these just came in literally 10 minutes ago. And what's the theory with these? It's a theory so far.
Yeah,
we
theory.
don't know.
We haven't actually tried this yet, but we're going to put a clamp one side to the other, and we're going to make a tool that will allow us to torque wrench these twists to the same tension on both sides. Because I think these will do what? 1,500
pounds
of clamping force. So one per side, overlapping our stack, so they don't reach all the way to the center, but they reach where the pivot area is and towards the tip of the blade.
So you're kind of squishing here and here, and between these two plates, it should stay parallel.
There's isn't enough of warpage for there to be any error theoretically.
Yeah.
But yeah, once these are both clamped down, then you can zap all these surrounding bolts around, and it should help it all stay even inside the plates. And then you can take these off, and it should stay nicely constrained.
Or possibly throw the cant twist clamps in the oven as well.
Yeah,
we're going to experiment.
So
we don't know yet.
These will react fine.
Yeah. Apparently these are copper plated steel.
Yeah, not copper
We
itself.
originally thought they were just pure copper, which wouldn't work in the temperature. Yeah, so that's one of our theory upgrades. Next week, we'll see what happened.
Yeah.
I have props to show you guys. So these water-cooled quench plates, we made these like, what, 4 years ago? Like, we've been using them for a while.
Yeah, like beginning of 2019.
Yeah, in the old shop.
Yeah.
So 2019. And for the most part, they've been quite amazing. Like, huge difference from the plate method we were doing before.
Yeah, massive improvement.
And you're able to suck the heat out fairly quickly. But in this whole process of conversation, we're like, what's the next step? What's the next, like, what can we do better? How do we do it better? Couple things we don't like about these. They're made from 6061, and it is a somewhat soft aluminum, but it does dissipate heat very quickly.
Yep.
So they're actually denting, because you're putting 1,000 pounds of force.
Yeah, so anything that's not the blade in there
Yeah.
will both indent the blade because it's super soft at near critical temperature, and indent into the aluminum just because of how soft it is.
This set has been used quite a lot. You can see indent of blades over time. I haven't measured it for flatness yet, but I don't really care at the moment. And then design-wise, I realized we've got a couple things going against us. This is what the plate looks like on the inside. So water goes in that port, water flows out that port, and you're transferring the heat through there. But what we did is we actually, this is your water plate,
On
and
the bottom,
this is your contact surface. So you have like some sort of an air gap in between that you're assuming heat is transferring through that air gap. Wouldn't it be better if you just, crushed right onto there, and had heat transfer quicker?
Yep.
But the thickness, and what I wanted to do was remove these, put them back on the CNC machine, and face them again down, which we did a couple times. We didn't do that too much.
Not since we moved.
Yeah, exactly. And so that didn't work out as well as I planned. And then now I'm thinking about it, I'm like, that gap in between can't be helping the situation either.
Yeah, I would be curious. We didn't actually try it, but I was wondering how much adding like a PC thermal compound kind of would help.
It could, theoretically, for sure. And then there's another plate on top that sandwiches the top of the cooling channels with an RTV coolant, or RTV sealant.
Yeah.
First time we used copper RTV because we're like, sweet, thermal dissipation, let's use copper.
I was always wary of the copper, and it certainly didn't work out.
It ended up like corroding, or helping to promote corrosion.
Yeah, it created a battery because of the two dissimilar metals and tap water. And it cooked the crap out of the inside of the aluminum plates, and I had to crack them open and bead blast all the corrosion off, and then we glued them back up with high temp black RTV.
Black
and they've
RTV,
been, let's say, mostly fine since then. We don't actually know what they look like on the inside since then.
Yeah.
So we'll find out once the new ones are together.
Exactly. So a couple of improvements there. Let me show you the new one.
Oh, it's
this gorgeous thing, made of 7075 aluminum, single piece, so not a bottom plate, a contact surface. Totally different cooling channels on the inside. We drilled features there, and including a floor feature on the bottom to introduce turbulence so that you don't have laminar flow going through it. You have this kind of agitation, which should theoretically
pulls more heat out.
Yeah, pull more heat out. And the other thing I did design-wise is,
Just
grab me a blade.
slam them wherever.
So right now, we're heat treating, or we're quenching like this. And we have warping issues in the long axis. So you have cold water coming in, and it gets warmer and warmer, and maybe that's contributing to the warp. So I was like, what if we put the cooling channels in this direction? So that if that's a theory, at least maybe you're warping now this way, which is a much shorter axis than the 5 inches that way. But your lengthwise warp might be eliminated with that.
It's kind of the same theory as aligning your parts on a surface grinder mag chuck with the poles of the mag chuck, right?
Okay.
You want it to be along the poles, not opposite the poles.
That makes sense.
You want the most magnetism across the whole part.
And all of these things basically help stack the deck in your favor, which we're really, we're grasping at straws here.
Yeah. Any semblance of improvement is improvement at this point.
And the reason I chose 7075 aluminum, which I've never really worked with, but it's twice as impact resistant, so the denting should be significantly less. It's a solid plate, so if we do have to take it out and surface it or lap it or whatever, we totally can.
A really nice finish on there already.
And I've already lapped, I started hand lapping this side. We'll talk about that more next week. I want to get this like dead flat. There's still about 3/10 lake in the middle here, high on the outsides. But it's getting really, really good so far, like shiny. Like you see your Sharpie. So that's good.
Knives and pens and mirrors.
Yep. Yes. And then instead of having hose barbs and rubber hose, we're switching everything to push to connect, plastic hose and stainless steel fittings, and going all throughout. Just, let's go full Grimsmo on this thing.
Yeah, making it easy to maintain, easy to upgrade.
Easy to pull this out, lap them flat again, easy to measure temperature, et cetera, et cetera. It's excellent. I'm very excited for all this. Now's a good time to show you guys the hydraulic pressure gauge. Come check this out.
Got a little rusty. We might want to put something on that.
Meh, it's fine.
Okay.
It's not rusting on the inside.
That's true.
So something we noticed, having, over time, we've had several different people do heat treat. Skye's done most of it, but we've had other guys do it too.
Steven did a fair amount while I was
he did.
back in school.
And so when you're quenching, if you, maybe step back a little bit, if you just go like this, how much force are you putting on it? I don't know, I'm using the arbor press. Whereas another guy might be like really like putting his entire weight on it, or you might, be all gung-ho in the first 5 seconds, and then you get a little lazy, and then you taper off, and then you don't know what's happening, right? So to eliminate that variable, that consistency, I developed a hydraulic cylinder in here, just using scrap parts. That's why everything looks kind of weird, because I had this steel laying around already. But inside, I'm going to show you guys a CAD file of it in a second here.
We'll take it apart when we swap the plates out. We'll show,
maybe, well, it's full of oil.
Well, the rotational surface at least.
So basically, it's on a hinging joint, which allows a little bit of compliance and play, because this whole system is not sturdy enough to be precision, but that's fine. Allow some hinge, let it self-center itself, that's fine. So inside, I have a little piston with something like 1.128 inch diameter bore, which equals exactly 1 square inch of surface area. And it's filled with oil. We have this oil drain here. So I was actually able to fill it and purge it out the vacuum, or the pressure gauge side. So there's no air bubbles inside here. And basically, as you push on it, you can see, because the cylinder has 1 square inch of surface area, it's 1 PSI equals 1 pound of force. So with a little bit of force, I'm putting 500 pounds of force on it, exactly. And right where this bubble is where 1,000 PSI is. And I can even lean into it, give it 1,500 PSI with some decent effort.
Bending the table effort.
Yep. And whatever the number is, we don't know, but as long as we're consistent, as long as you're given the same thing. So 1,000 PSI is our current goal. And I mean, so this is 500 PSI. I could do it with, not 3 fingers, but I can do it with a hand easily. But to do 1,000, I got to go like this, and to do 1,500, I'm like on my tippy toes. And I bet you I can do 2,000 if I'm floating.
We used to do 2,000.
Really?
We're finding that it's very easy to actually squish part of the blade and have it end up thinner than the rest at 2,000 pounds.
Okay.
And then,
oh wow.
Yeah, trying to reduce the crushing and the indenting from particulate being on there, I had backed it off to like 750. 750 was not enough.
Yeah,
so
yeah.
1,000 is like probably right at the, getting in the sweet spot of flat but not squished.
So if I'm off the ground, I'm at 2,800 PSI, 2,800 pounds.
And that's without putting a cheater bar on the arbor press or anything like that. It's just, I don't remember the exact force multiplier of that arbor press. But
yeah, it's, I don't know, but
it's
there's gear ratios in the arbor press itself, right?
Yeah.
That's why my 167 pounds like leads to 2,800 pounds, whatever that multiplier is right there. Cool. So that has been hugely helpful.
Yeah.
And the new plates this will bolt right to the top of the new plates, no problem. And then you can see the hoses here coming out. We have 2 feed hoses feeding the top plate and the bottom plate, and then 2 drain hoses coming out, draining the top and the bottom plate. You see our tank temperature is now up to 81 degrees. It was 74 when we started this. And then I'll take you over to the pump side right now. So super simple setup. We just have a 5-gallon bucket here with 2 aquarium pumps inside. One for the top plate, one for the bottom plate. And then the drains come back like so. And the water is warm.
Yep.
Like, that feels like nice.
Yeah, like summer pool warm.
Yeah, exactly. Not as warm
crazy.
as Larry's pool was. So it's like 81 degrees, depending on how accurate that cheap thermometer is.
And you might have noticed that the flow right now is quite poor.
Yeah.
It's definitely gotten worse over time, even since we've changed to those new pumps, which was not that long ago.
You've noticed that the water gets dirty and scummy and algae-y. And
yeah, the heating up and cooling down is a great promoter of bacterial growth. And it's open atmosphere, and it's RO water, so not tap water.
Okay,
so we
that's
don't
good.
have mineralization, which also contributes to those things, along with corrosion. RO is almost as good as it gets for just water.
DI
we
water
change
is
it-
even better.
Yeah, we change it
But
often enough that it doesn't get
Good.
super gross. But yeah, there's floaties in there, and they clog up the pump, they clog up the plates, they clog up the lines. One of the improvements going forward is to have a filter,
Yeah, I'll show you guys right now.
and that should just be better.
Skye and I took a field trip yesterday and we went to Murray Hydronics. Did you guys know hydronics is a word? I didn't know that originally. Like hydraulics, yeah, no, hydronics is the industry of pumping, right? So they only sell pumps. So this is a Pentair SureFlow pump. It wasn't cheap, it was like 300 bucks.
Yep.
And the fittings were another like 70, 80 bucks on top of that. But it's a diaphragm pump, super awesome, gives 3 gallons per minute at 45 PSI. There's actually a pressure valve inside that can turn it on and off based on that min and max
That's
pressure,
interesting.
which is kind of cool.
I don't know if our other one has that. Maybe it does.
And we do have one of these pumps over here. We use it for the tumbler evacuation
We've had like
sometimes.
5 of them, and they're great.
Not of this brand.
Yeah, we have.
Yeah?
Yeah, we had
Cool.
like a huge one, and then we had a couple smaller ones. We've gone through, that's like at least number 4.
Cool. Let me show you the filter over here. So throwing everything we have at this, just kind of a whole house filter, super basic. And then this bad boy is our aquarium chiller that we're going to add. So we're going to be able to chill the quench water and have it be exactly 70 degrees and stay 70 degrees no matter what.
Yep.
And that just adds another layer of consistency and takes a variable out of the equation, which I think will be great. So anyway, in the next video, we're going to do all this stuff. We're going to actually do it and see what happens.
Or it'll be done.
Or it'll be done.
We'll probably film a good amount of the actual upgrade process.
Yeah, we will. So anyway, I think that's all I got. All in the name of flatness. Negative 321 degrees Fahrenheit. It's dripping.
Yep. Well, they're submerged.
Nice.
And if you hang them like this, they'll get all nice and frosty and crystallized by condensing the moisture out of the air.
All right, guys, on that note, see you next week.